can hop on. Yeah. Okay, guys, I'm Todd Underwood. I'm helping Matt host today. We've got about 4 or 5 people hopping on. We'll get here started in about 1 minute, Matt. I'll give you a thumbs up when we're ready to go.
Fantastic. Got a participants button. I can see who has joined us. Fantastic. We are set to start at 10:30. We'll give it a few, maybe a minute or so here, and then we will dive in. The Smart Manufacturing and Food Processing Applications, the sequel. Not sure how many of you were able to join us for the first iteration of this webinar series back in January. We'll talk a bit about that. Will be covered as we get going. And then we'll spend a good portion of the time today talking about a type of technology in the space that we purposefully avoided in that first webinar. That being industrial AI algorithms and predictive data analysis. That's going to be a good portion of what we talk about today. All right, I think we're good to begin. It's 10:32. Folks will hop in as we continue here. Good morning, folks. For those who don't know me, my name is Matt Iniger. I'm a project engineer here at the Center for Innovative Food Technology. I also manage our Advanced Food Processing Technology program, which is one of our funding programs available to members of our Innovation Consortium. Excited to talk about, continue to talk about how smart manufacturing and Industry 4.0 technologies can be applied in food and beverage manufacturing operations. It's something that's not only am I passionate about, but I get the chance to work quite a bit in, and we, SIFT, have had the opportunity to support through our Advanced Food Processing Technology program. We'll talk a bit about how that works at the end as well. So that's a little about me. Let's go ahead and dive in. Let's go to the next slide. Before we talk about, I didn't do anything, just click the button. Before we talk about some of the technologies that we're going to look at today, I want to take a few minutes to talk about SIFT as an organization. I know this will be old news to some of you, but we'll get through it quickly here. The Center for Innovative Food Technology is a private nonprofit. We've been around for over 25 years with the express purpose of driving improved competitiveness for food and beverage manufacturers and agribusinesses, specifically in our region, in our state, and in the Great Lakes area. We're really passionate about what we do. We're a small team, but we've been able to do a lot in the 25 years we've been around. A little bit more about us here. It's really easy to get caught up in a lot of the details about what SIFT does. For those of you on today who work with us, I'm sure you understand, the various things we have our hands in. It can get complicated, but when you really boil it down, what we are is a nonprofit technical service provider, right? Specifically for food and beverage manufacturers in the state of Ohio and nationally through our manufacturing extension partnership network, as well as discrete manufacturers here in our 18-county region in Northwest Ohio. We do a decent amount of work in that space as well. So that's what you can think of us as. We are consultants at the end of the day. That's what we do. We come in and help you solve problems, but we do it in a unique way through being a nonprofit organization and being a part of the network that is the Manufacturing Extension Partnership, both the Ohio chapter and the national network that operates through the federal government. A bit more about who we serve. Obviously, you folks are here as food processors, food manufacturers. We do serve some other groups as well. I talked a bit about what we do for discrete manufacturers here in our region. We also support startup food businesses. We're really, really proud of that program and what we do there with the goal of continuing to foster a culture of innovation in our industry. We have a facility and some other programs and services set up just for people who are either pre-revenue or in the very initial phases of commercialization for a food business. And that's really cool. Not going to talk really that much about any of that today, but did want to highlight that we do some other things besides just talk about really cool advanced technology for mid-sized to large food manufacturers. A bit more about what we do as a team that works in the food industry. Our services can be broken up into a couple of different areas. We do product development support. There's a whole bullet point list of things we do here. A lot of you have made use of these various services in the past. We also do a lot of food safety work, especially regarding third-party certifications. That's very much in demand these days, and we're able to support pretty much any phase of that process. So that's something that we do a lot of. And then today, obviously, we're talking about an aspect of our process engineering division. You can see it on there. Smart food manufacturing is actually the last bullet point. But we do a lot of work in terms of facility design and commissioning. We do a lot of process design work. We integrate new process equipment. We also do material handling and wastewater design, if that's something that piques your fancy. And then we do quite a bit of work in robotics and automation, specifically administrative automation, which we're going to talk about in a bit. And then all the things we do lead to some pretty awesome outcomes for our clients. If you're one of them, thank you so much for supporting us. We're really happy that we're able to drive these kind of economic numbers for our industry and for our region. So that's a little bit about SIF. Now let's dive into smart manufacturing. And the first thing I want to talk about in regards to our actual topic today is a bit about what we discussed in that first webinar back in January. Some of you may have attended it, some of you may not have. So real brief overview. We began talking about the things we aren't going to cover. We're going to do that again here. It's really important to differentiate clearly what we are talking about and what the purpose of what we're talking about is. I want the goal of this meeting that we're all in here to be for all of you to learn something new, but particularly to know enough information to be interested and not be overwhelmed, right? We're going to talk about some things at a 10,000 foot level as an introduction to certain technologies, right? This isn't supposed to be, a graduate level seminar or anything in super technical detail, but instead is supposed to serve as an introduction to certain tools that can benefit your businesses that lead to follow-up conversations, both with myself and with our partners who are technical experts in this area, to really nail down the specifics. So there's, like I said, similar disclaimer about what we aren't going to cover. There'll be a little more about that in a second. We then talked about briefly what large-scale industrial data collection analysis looks like. We're going to spend a lot of time today talking about that. That is the purpose of today's webinar. We're going to talk about industrial AI. We're going to talk about predictive data analysis. That's what we're going to talk about. And the reason we didn't talk about it in the first webinar is the goal of that session was really to explain the very, very basics of smart manufacturing, which is really just let's make better decisions in a manufacturing operation. That's the ethos, so to speak, of what we're trying to do here. Now we're doing it with really interesting technologies. That's where the fancy words like I 4.0 come in. But at the end of the day, what we're trying to accomplish with smart manufacturing is better decision making. So we spoke a bit about how people make decisions now, which can be done in a variety of ways. The most common way, of course, is by utilizing some amount, for a lot of manufacturers, it's a very large amount of tribal knowledge. And that's really the main pain point that smart manufacturing is attempting to fix. It's not just higher quality decisions, it's more sustainable decisions, right? The decisions are wrapped up in the head of certain people, whether they be in leadership or just operators who have been there for many, many years and seen many different situations. That is a large risk for a manufacturing operation, and we want to mitigate that risk. We talked a good bit about manual and automatic data collection. Like I said, this is an introduction to how to use data that your process generates to make better decisions. And so it doesn't have to involve, right? If you're just getting started and your business isn't super large and you don't have a large amount of a budget to expend on something like this, it doesn't have to be complicated to begin tracking important process metrics. So we talked a bit about different tools that fit in different budgets, whether they be manual or automatic, to actually collect process data rather. And then we talked about why we analyze the data, what we're trying to do, and went over a couple of tools that are really easy to get into to do that, as well as some tips on integration. So that's what we talked about before. And the reason I wanted to bring it up here is I'm going to talk today as though you did all this, right? So you came to the first session, or you didn't, and you already have, in a lot of ways, an understanding of the importance of this technology. You have robust data collection systems in place. You understand the value of analyzing data, and you want to do that in the best possible way. That's the underlying assumption of what we're going to talk about for the rest of the day. A few more housekeeping notes. Like I said, want to differentiate again, importantly, between types of automation. People say the word automation a lot, and certain people think a lot of people think of physical automation, which is automating out a physical task, right? That's where we talk about automated process equipment, robotics, physical automation. We're going to spend a lot of time today talking about administrative automation, which is automating out administrative tasks, right? There's a bunch of ways to do that. Pretty much all software is automating administrative tasks. Excel macros are automating administrative tasks. Industrial AI is automating administrative tasks. So we're focusing on that area. I got an awesome quote. I was lucky enough to do a little bit of specific FANUC integration training on the robotics end a couple of weeks ago, and the instructor had this awesome quote. That the answer to every problem is not a 6-axis robot. I think a lot of people come at the question of capacity increase, and they say, okay, time to invest in capital, time to buy a piece of equipment. That's what this means. I need to make more products, got to buy equipment. That is not necessarily the case. We talked in the first webinar a lot about entirely investment-free methods of improving your efficiency using data. Today is not investment-free, but it is also not another machine, right? That's not always the answer to every automation question. Another important thing to keep in mind is the difference. I'm going to say AI, artificial intelligence, ML, machine learning a lot. And those words can mean different things. In popular culture today, AI means large language models, GPT-4, Google Bard, software algorithms that talk to you. Those are awesome. They have awesome use cases. For the SIF members who are here today, they just got an awesome presentation on the use cases for such administrative automation, right? That makes your office jobs way easier. We're not talking about that. We're talking about industrial AI and predictive data analysis. And the main difference, there's two main differences between them. One is obviously the goal, right? Algorithms you design for your internal manufacturing operations are not going to talk to you. That's not the purpose. And second is the data source. LLMs utilize, they scrape data off of the entirety of the internet. That's how they are trained in order to know what word to respond to you with when you input some certain phrase. There are pros to that, obviously, in terms of the amount of data they can consume. There are cons to that in terms of data security and specifically AI hallucinations, because there's a lack of certainty around what data was used to train your bots. Those concerns are not as relevant to industrial AI because, as we'll talk about, you are training a computer on the data your process is generating, right? Which means, yeah, it's potentially less data, although you'd be surprised at the amount of data points the processing can generate. But it also means you have control over the inputs, right? You have control over how your bot is trained. You can be a lot more confident in results because you're not, there's no question marks around what, garbage in, garbage out. There's no question about what's in. Whether or not that's garbage is your problem, right? So that's a bit of housekeeping notes before we talk. And one last thing I like to bring up, ERPs and MES systems are a big topic of conversation in smart manufacturing. The smart manufacturing world, maybe number 3 in the series will be on that. That's another form of administrative automation, right? You're automating out the order processing, the process of doing business is being automated. In this situation, we are automating out the process of thinking, really drawing conclusions about our process. That's what we're doing. So a few more bits of housekeeping. So let's dive in. One more thing, we've had a couple more people join us. If you have questions, just drop them in the Q&A as we go, and I'll stop and go over them. We'll also have some time at the end to talk over some questions. So if you have any questions, go ahead and pop them in there at any point. So let's talk a bit about specifically industrial AI and predictive data analysis. Like I said, we are automating out, we are outsourcing thinking to a computer in order to find correlations and patterns that we are not going to be able to see, due purely to volume of data processed and calculations performed, right? We talked a lot about in our first webinar about data analysis, right? And it can start as simply as Excel line graphs, which are awesome and can tell you a lot. And I've been a part of Six Sigma initiatives that work solely through Excel graphs. But you can only make so many Excel graphs. One of the benefits of using a computer that uses artificial intelligence and machine learning algorithms to process your data for you is that you now have the ability to correlate and cross-reference unbelievable amounts of data, right? We have two examples here that come from our partners. We'll talk a bit about our awesome partners in the space. This first one here regarding specialty agriculture, SIP was not involved in that. That's kind of the go-to success story for our partners over at Delta Bravo AI, who we're actually going to use a lot of information they provided over in the past to us to talk about how technology works. Specialty ag, right? There's an opportunity here to optimize soil production, right? Feedstock production for mushroom growth. And biological processes are really, really hard to model because there's a ton of inputs, and it's really hard to really understand how inputs lead to outputs, except when you have the ability to measure and track and input almost every piece of data your process generates, which can vary from what you would expect, right? Like what the components of the soil are. Like let's keep track of the various percentages of our raw materials in our formula at a given time. That's easy, right? But what about the last 10 years of external historical weather, right? It's very hard to manually check for correlations between external weather. But when you are working with a group that already has a large amount of weather information backlog, and you're working with artificial intelligence that can perform this analysis for you, you're able to do that, right? And we'll talk about how you go from taking in this data to leading to profitable results in a second. But the point of this success story is we're going to improve yields by improving our formulation process by ingesting humongous amounts of data on biological processes. The second one is actually a project that's just supported through our Advanced Food Processing Technology program, which had to do with meat processing, right? Which is another sort of inherently hard to model process because of its various biological components. And what we tried to do here is reduce the cook time of pork bellies in the initial step of a process to number one, reduce cycle time, right? We wanted to increase throughput, right? We talked a lot about capacity increases that aren't a piece of equipment, as well as reduce scrap rate, right? And the goal of both those things were to, there was a choice presented to our client, right? Which was we need more capacity for our product. And the null, decision here was build a new facility, right? We need another plant to meet the demand. And instead of that, we underwent this industrial AI initiative, and we're able to get the kind of capacity increases that we needed without investing in additional real estate, this kind of highlights the magnitude that this technology can have when applied appropriately to correct use cases. This didn't look at nearly as much information, right? The process is substantially more closed. There's less data to gather, to be quite honest, but you don't need 100,000 data sources to appropriately use industrial AI and predictive data analysis, because, as we'll talk about later, the AI aspect of this involves your algorithm getting better over time at predicting process outcomes because it's being trained consistently on new data that your process is generating. So those are two very great examples of how this technology is in use with people in our industry, with SIP clients that go about it in two very different ways. So that's why I wanted to highlight both of those. Like I said, we work with awesome partners. I am not a coder by training or by passion. This is a very complicated technical process to pull off. Certainly, there needs to be a baseline understanding of how food manufacturing operations work in order to sort of marry the two subject matter experts in terms of data science and food science. And that's where we can be involved in the development and deployments of these systems. But we do work with great partners to make this happen. I highlighted a couple of them here. Delta Bravo AI is who did a lot of the work we're going to talk about today. The two success stories we just talked about that came from Delta Bravo, and then we also work with Soothsayer Analytics. They're a Columbus-based firm. They're local, which is why I wanted to bring them up as well. And they do similar boutique industrial AI algorithm development. So if you want to have the systems that we're talking about today, the very customized AI algorithms that are looking for specific outcomes for your specific process, trained on your specific data, it's going to involve boutique development. There's no off-the-shelf solution for this, which is one of the reasons why we refrained from talking about it previously, because this is really for mature businesses that have mature processes that are ready to automate. But we do work with some awesome partners to accomplish this. So shout out to those guys. Shout out to Delta Bravo, who gave us a lot of the information for today. We're going to go over a couple of slides from them that kind of explains how this technology works. And this is really an awesome graphic. I love to use. It looks like it got cut off a little bit, unfortunately. Only a little bit though. At the end of those two arrows there for analytics and machine learning and AI. Just know there are dashboards and profitability matrix on both sides of those. We'll take a look at those in just a second. But what this is a graphical representation of what we're talking about, right? You're bringing in lots of data sources that are very diverse in terms of what the format, whether they're numbers or strings, how with digital analog signals. There can be a bunch of ways you can collect data. And one of the benefits of working with a group like Delta Bravo to do custom solutions is creating what data scientists call a single source of truth, right? Delta Bravo goes through several steps to get to that. That's the purple cylinder down there. That is a data warehouse. It's a single source of truth that all of your process data systems can run off of. That way, you can, like I said, you can trust the conclusions and the outcomes that your systems are generating for you. That is a substantial amount of work, and it's very hard to do, which is one of the reasons why this is a bit of an investment, requires specialized people to pull off, is in order to create this data warehouse. Once you've done that, right, you train your AI algorithm on that data warehouse, which leads to certain outcomes, right? We'll take a look at one of those outcomes here. So this is an example of some of the data inputs, right? This is specifically for the mushroom success story we talked about just a second ago. There we go. There's the stuff that I thought got cut off. Excellent. So you can see here what the outcomes are. We'll take a look at a profitability matrix here in a second, but this is a great graphic that kind of explains the process in terms of how this system takes data inputs and leads to conclusion outputs. Here is such a conclusion output, right? And this is where we start talking about the predictive side of predictive data analysis. Due to the real-time collection of data, the real-time analysis of data, which you can do once you have excellent understandings of the correlations between inputs and outputs, is you can predict in real time what the outcome will be of your process based off of the data you're collecting, right? This is a profitability matrix for that mushroom project we talked about earlier, right? Where based off of data that's coming in about your formulation and about your growth environment, Delta Bravo could predict for their client the success of this batch of mushrooms, which provides you a lot of valuable insight from a process efficiency standpoint, right? Process control is very, very important. And this doesn't quite allow you to see into the future, but it's very close. It's very close to seeing in the future. And a very popular sort of commercial application of this sort of technology is predictive maintenance. That's something that can kind of come off the shelf, and certain equipment OEMs even offer, I think, predictive maintenance algorithms on their equipment, and it works in a similar way, right? Only this is predictive maintenance for your entire process, and you can understand before a problem occurs whether or not it will occur and how likely it is to occur, and that ability to make better decisions, right? As we go all the way at the beginning, why do we do this? We want to make better decisions. This is the best possible information you can have at your disposal to make the best decisions you can. That ties us back in to the purpose of smart manufacturing, right? Some more benefits of this technology. We talked about some of these kind of as we went through how it works. One, obviously, is just volume of correlations, right? By outsourcing your thinking to a computer, you have the ability to check every potential correlation for positive outcomes. We talked about this a second ago, continuous future state information, right? You can know ahead of time, in real time, whether or not production issues are going to arise. An important aspect of this we talked about just briefly is that because this is internal data, your algorithms are going to improve over time as you collect and train your bot on more data, which is awesome. So, as you operate this algorithm in your operations, you can get better and better predictions of outcomes. So that's also really cool. And then we talked about here as well, it's feasible to tie in the outputs of these predictive data analysis algorithms to process control, right? So you can make, not only can you respond to these predictions manually, right? That's I think kind of probably the most common, from what I have heard from our friends at Delta Bravo. That's a very common way that these are acted upon. The predictions are acted upon, but it's feasible to automate. We get back to physical versus administrative automation. Now you're tying this into physical automation. You can actuate some sort of physical automation based off of the output of your predictive data analysis algorithm, right? So very, very, very robust automated process control from a quality standpoint, and that's really powerful. So that's some of the reasons why this is a technology that's very much worth investigating for manufacturers who sort of fit the criteria to be ready for it. Let's talk a bit about what if you're not, right? What if, SITS works with a ton of small to mid-sized manufacturers who do a lot of really great things, but maybe aren't right now have the ability to invest, either don't generate the process data that might be required to get really good results, maybe don't have the budget to afford a $500,000 investment into this sort of technology. A bunch of reasons why maybe now is not the time. How can you prepare to utilize this as your business grows? And this ties us back to our initial webinar in this series, right? Design a process that is generating good data and build a culture of collecting it and using it. The number one way you can do this is begin with really basic process KPI tracking, and that can be manual. That can be, twice a month you run out to your packaging line and count the number of packages that are coming off a minute, right? Really basic, but important to have some idea of what sort of data your process is generating and know where you might want to look for inputs to such an algorithm in the future. Speaking of inputs, right? If you know that there are really high impact data sources, we talked about packaging throughput. There's other ones, right? Let's say that your production just slows down a ton in the summer because it's hot for whatever reason, whatever that your product is somehow affected by temperature, humidity. Then, even though you don't know exactly how it's impacted, it is impacted. It's probably worth, a much smaller investment in a weather station that can monitor internal temperature and relative humidity, because that automatic data collection is going to be really important in this sort of system years down the road. Right. So if you do know what your high impact, your low hanging fruit, right, in terms of data collection is, taking steps to automate that now can set you up for success in the long term. And of course, there are ways to get turnkey audits in this area, right? We've talked a lot about Delta Bravo, one of our partners. They do a data readiness assessment, right? Let's say you have the ability to proceed with this, but you really don't know if your process is a good fit, or you don't know what your use case is, what your output would look like, that can be the target of such a data readiness assessment. Or let's say you're a decade from this and you want to have even more in-depth recommendations on how to set up over the next decade to prepare for this sort of technology. That could also be the target of such an assessment, right? So that's something that I would absolutely encourage you folks to utilize. That SIP is happy to support if we can in whatever way we can. So these are some quick tips on ways that now isn't the time you can begin to investigate or prepare for a future where it is much more viable. So that is sort of the 10,000-foot of view of industrial artificial intelligence and predictive data analysis. Real quick as we wrap up here, I want to be cognizant of everyone's time. I want to talk a bit about SIS membership consortium. Because of how that can potentially assist with integration. If any of you folks come away from this with a desire to really thoroughly investigate this and potentially utilize it, there are ways that can be a part of that, and that's through our membership consortium, right? So there are several members here already. Thank you for joining us. Thank you for supporting us. A bit about what we do. It is a network of food manufacturers, companies who are adjacent to food manufacturing, technical service providers, equipment OEMs, ingredient suppliers. And that network obviously gets together to share best practices and support technology commercialization. There's also a certain service aspect to our membership. Folks who are members to receive, we'll just hop over to the next slide. Folks in our membership do receive further discounts on SIF services. and discounts on trainings that SIF does from a food safety standpoint. Access to certain complimentary remote consulting. So there are service oriented benefits to being a part of our membership consortium. But additionally, where this is relevant now is that, like I mentioned, the meat processing use case we discussed a bit earlier, that was supported through SIF's Advanced Food Processing Technology Program, which is a unique funding program that is only available through membership in our innovation consortium, with the goal of commercializing advanced technology in food and bev. So that is could be a great fit depending on your use case and a bunch of other qualifiers, of course, for support by that program. And this is relevant now. We just launched our RFP for 2024 for that program. So we are taking proposals for projects that we could support through that program for next calendar year. If you're interested, if you're not a member and you are interested in becoming one in order to access that program and submit a proposal, please get in touch with me. I would love to talk about a little more in detail about what that program looks like, what membership looks like, how we would put a proposal together in order to be considered for support. So I wanted to touch on that just briefly for folks who aren't already members, as that could be a great way to, if you're ready to move forward and you're excited about this technology, it's definitely worth looking into ahead of time. One last thing about SIFT, super happy to shout out the Manufacturing Central Partnership, which supports a lot of what we do. That's a reason why our team's expertise is more subsidized than you would find from other people in the space. It's a reason we're able to do great things like the Advanced Food Processing Technology Program. So very happy for the state and federal MVP support, as well as the Sustainable Food and Packaging Initiative, which is a homegrown group here in Ohio with the mission of improving the materials with which our food is packaged in order to have positive impact on our environment. So a couple of more shout outs to those groups who are proud supporters of SIFT. With that, folks, I appreciate the half hour you spent with me today. I hope you learned something. Some of you who know me have probably heard me talk a bit about this in the past, and maybe we're interested in more detailed information about how this works and what the outcomes are. Like I said, this industrial AI is a substantial investment. It takes a certain amount of willpower from a business to want to do this, but the payoffs are tremendous. When we're talking about the differences between building a facility or not, we're talking about, you're talking about 7-8 digit ROIs. So this is a serious technology for serious manufacturing operations. And for those of you who are in attendance from such operations, please let me know if you're interested in learning more. For folks who are here to learn and excited about this technology in the future, we can also help there. Feel free to contact me. There's my email and phone number, which most of you have, but if not, please let me know if you have questions or are interested in learning anything more about membership. So with that, I haven't seen any Q&As pop up as we've been going here. I know it takes a few minutes to type, so jump off if you want. If you have a question, I'll be around for the next 5 minutes here hanging out as you type Q's, and I will provide the A's. Folks, thanks again for your time. Have a wonderful rest of your week.
Also be aware that this recording will be uploaded to SIF's YouTube channel probably by the end of the day or early tomorrow. So if you want to record your recording or share that to anybody, check out and subscribe to SIF's YouTube channel, and it'll be available there within 24 hours. Also, if you're still on and you want to just actually speak your question, if you just hit the raise your hand button, you can actually speak as well if you'd rather not type it.
Awesome, folks. Well, it looks like there aren't any other questions. So thanks again to the folks who are still hanging out with us for coming out. We'll close the webinar up right now. And like Todd said, you can find it on YouTube if you want to reference any of my sage wisdom or any of my beautiful slides. So you'll find them there. Thanks, folks.